Alright, so in today's video we'll be looking at the exponential equations, right? So in our prior video we looked at expressions meaning simplifying, making it simplifying completely. Now in this case we're looking at exponential equations. Now that means when we're dealing with equations, that means that we are solving for a certain variable, right? Most of the time we'll be solving for x, right? So in this case we are solving for a certain variables. Now there are three common types of questions that mostly pops up on the exams, right? So we're going to look at type 1. So let's look at type 1. So the first one that one should know is when we are dealing when they want you to solve for x, right? And x in that case is a base, and then let's say x is raised to the power something, right? Let's say a is it's some number, and then which is equal to b. Now in that case, how do we remove a, or how do you make x the subject of the formula, or how can you solve for x in that case? So here that means if you want to solve for x, we have to remove the a. Now how do we remove the a? Well, there are multiple ways of doing this, but of course the easiest way is to introduce 1 over a on both sides, on the left hand side and the right hand side. So meaning if I have x a equal to b, well in that case I'll introduce 1 over a on the left hand side, and whatever I do on the left I do on the right. So meaning in that case, if you times these two, you will have x a over a, which is equal to b 1 over a. So in that case here these two will move, and hence you have x equal to b 1 over a, right? I hope that makes sense. So let us look at another one here. Let's say an example, we have x cubed, right, is equal to 8. Let's say x cubed is equal to 8. Go ahead and solve this equation here. Solve for x. So in this case here we're going to introduce 1 over 3 so that the tree can move, and we have x independently, right? So you're going to have x 3, and then we're going to introduce 1 over 3 on both sides of the equations, right? And here you're going to remove these two, and then we have x on the left, and then here you're going to have 8 1 over 3. Then you can just plug this in a calculator, but this is the same as the cube root of 8, which is 2 in that case, right? So that is how we solve equation when we are dealing with x as a base, and we only have one, or rather we have a digit as an exponent, and yeah, that's how we solve in that case the tree, right? As I say, there are multiple ways of doing this. You can introduce the logs, you can introduce ln, or you could say, well, x cubed is equal to 8, and then you can cube root both sides so that these two can move, and hence we have x equal to 8, right? There are multiple ways of doing these, but for now we're just looking at this simple way of doing it, right? Yeah, this simple way of doing it. So this is the first step, or rather the first thing one should know, right, when solving for x, right? Okay, let's look at type 2. Right? I hope that everyone now know or understand type 1 is very simple, and then type 2. So type 2, when we have x as a base, or rather let's say we have a number as a base, meaning, and then x as a exponent in that case, and then we have x as an exponent, we have 3, then we also have let's say on the left I have 3 2. we have a 9, right? So what does that mean? Well, you can put a 2 there, it doesn't matter. So how can we solve for x in this case? Remember that we did changing these numbers into the factor of the power factor of prime factor in that case, right? So meaning I could change this 3x equal to 3 squared times 2, right? So that will mean I have 3x, which is equal to 3 raised to the power 4, because 2 times 2, that's 4, and then x will be equal to 4. Now why is x equal to 4? Well, if I'm saying 3x is equal to 3, 4, if there is a equal to sign here, that automatically means that this side is equal to this side here, right? Now the bases are the same, so that means these two have to be the same as well in order to make the left hand side equal to the right hand side in that case, right? So we're going to equate the two exponents, right? Similarly, when you're dealing with the expression, rather if you have some equation on top, right, a polynomial, right? If you have a polynomial on top, let's say x plus 1, which is equal to 9, right, can also do the same. 3x plus 1 is equal to 3 squared. Again, what I'm going to do, I'm going to drop the exponent, I'm going to drop the bases, and hence whatever is left on top I equate, and then I basically solve for my x in that case, right? I basically solve for x, right? Let us look at one more example here. Let's say you have 27 raised to the power x times 9 raised to the power x minus 2, which is equal to 1, right? So in some cases they'll throw you off and then they'll put a 1, but you know a 1 can be any number, can be 27 raised to the power 0, can be 27 raised to the power 0, can be 1000 raised to the power 0. So it can basically be anything raised to the power 0. So note that as well. Okay, so my 27, what is 27? Well, 27, if you do the remember when we are dealing with exponent, you always want to make sure that the base is always in the form of is in the form of a prime factor, right? It is always in the form of a prime factor, right? So you want to change this 27. By changing this 27, you're gonna go to your calculator, plug in 27, and then press the equal to sign, and then press shift, and then press fact, right? Then you're gonna get that answer there. So basically the prime factor here will be 3 raised to the power 3, and then times that x, right? Do the same with a 9, so it will be 3 raised to the power 2, and then times x minus 2, which is equal to 1, right? And then I'm gonna times this inside, therefore 3, and then x times 2x minus 4 is equal to 1, and therefore here I'm multiplying the same bases, and hence I will add the exponent, so meaning I'll have 3, and then yeah, it should be 3, right? So 3x plus 2x, that is 5x minus 4, which is equal to, in that case, 3 raised to the power 0. So the bases are the same. I'm going to equate the exponent, so minus 4, which is equal to 0, and hence x in that case should be equal to 5, or rather 4 over 5. And then take this value here, put it in your original expression, and you'll get your final answer as 1, right? You should get your answer as 1 if you did your math correctly. Okay, so let's move on to another one. Let's move on to the last type here. I want to keep this video as short as possible, so so let's move on to type 3. So type 3 is basically looking at the common factor, right? Basically looking at the common factor, right? That's type 3. So for instance, if you have 2 raised to the power 3x plus 1, and then plus 2 3x, and then equal to 12. Now whenever you have an addition or subtraction, there will always be a common factor. You always have to do a common factor, unless if it is in the form of a quadratic equation. That means that you will have to factorize letting something equal to k and then factorizing on the whole step. But in this case, you can see that you have 2 3x here, then here you have 2 3x here, meaning there is some sort of very easy common factor in this expression here, rather than this equation, right? So I'm going to take out 2 3x, and I'm going to say times, well, 2. In order for us to get 2 raised to the power 3x plus 1, we should times this by 2, that's a 1. Same basis at the exponents, 3x plus 1, and then plus 1, which is equal to 12. Right? I hope that makes sense. So this here is basically the same as this expression there. Right, so again, if you multiply inside, that times that will give us 2 3x plus 1, and then that times that will give us plus 2 3x, right? So that is what we mean by taking out the common factor, right? Okay, so in that case now I'll have 2 3x, and then times, well, 2 plus 1, that is 3, which is equal to 12, and then I can divide everything by 3. Can divide everything by 3, hence I'll have that over that, and hence I'll have 2 3x equal to, well, 12 divided by 3, that's 4, and hence now I go to type number 1. I go to type number 1, or rather no, type number 2, right, where we want to drop the bases, right? We want to drop the same bases. So here again I can say, well, this is 3x, which is equal to 2 squared, right? And then I'll drop the bases, hence I'll have 3x equal to 2, hence my x will be equal to 2 over 3, right? And then you double check this by putting this x value by putting this x value on the original equation here, right? I hope that makes sense. And in our next video we'll be looking more examples. We'll be looking at examples